Hi there, so today we're going to solve this problem called maximum product subarray. In this problem we have to find a subarray in the given array that gives us the maximum product of the values. For example, if we have our array as 2, 3, minus 2 and 4, the maximum product that we can get will be 6. Okay, now again this is a subarray question. So the brute force approach will be that we generate all subarrays, but that would take a time complexity of O of n cube. Then we can reduce it using a prefix or suffix array and get a time complexity of O of n square. However, if we observe, it is given that any prefix or suffix of the array will fit in a 32-bit integer. So we can use this observation and another observation that the answer will either be the prefix of the array or the suffix, or if we encounter a 0 on both sides, it will be in the middle. The maximum will be in the middle, prefix or suffix. Okay, so maybe we can calculate the prefix and suffix and then take the maximum of them, and that would be the answer. Okay, let's try that approach. First, let's get the size of the array. Let's say nums.size, and we also need an answer variable. Let's assign it int min initially. Then prefix will be equal to 1, suffix will be equal to 1 initially, and let's just iterate from 0 to n minus 1, and our prefix will be multiplied by the current element and our suffix will be multiplied by the element at the right side n minus I minus 1. Okay, and our answer will be maximum of prefix, suffix, and of course answer. Right, but that just gets us the prefix and the possible prefix answer and the possible suffix answer, but we also want the middle. And when do we want the middle? When we encounter a 0 from both sides or one side, let's say. Okay, so what we're saying is if prefix equal to 0, then we want to restart the subarray, restart multiplying the elements of the subarray. And if it's suffix equal to 0, then suffix will be equal to reset to 1. Okay, and we will return the answer. What we are essentially doing is that this is a modification of Kidaine's algorithm, which is used for maximum sum of the array, and we can also use it here. Why? Because we want to maximize the product. So whenever the product is 0, we just reset, we just start getting the subarray again, getting the elements of the subarray from the start. For example, if we take an array, let's say 2, 3, 0, 1 and 2, and then there is 0 and 1 and 2. Let's say this is the array. Okay, then in the prefix we take this subarray, get the answer, which will be 6. Then we encounter 0, our prefix will become 0. So what this does is this resetting to 1 will start our subarray from here. From here, the next subarray that we will get in the prefix will be 1 and 2, and so on to the next elements. And again, when it is set to 0, our prefix will have 1. So this is what we are doing. Whenever the sum is 0, whenever the product becomes 0, we reset the our prefix variable to 1. Okay, does this work for the basic test cases? Yes, it does. Will it work for all the cases? No, it doesn't, because we have a test case like this, which is a very big array of a lot of tens. So how do we deal with that? We will deal with that by saying that okay, let's make the prefix and suffix a long variable, and our whenever our prefix goes lower than int min, or our suffix goes lower than int min, we will reset that. We will reset it. Why? Because we are given in the question that any prefix or suffix is guaranteed to fit in a 32-bit integer range, and if it doesn't, we can reset it. Works for the basic test cases. Will it submit? Oh, again wrong answer. Output 0 should be 1. That should not have happened. -3, 0. Then we abandon -3 and 0 and restart the subarray at 1. In suffix also we do this. It should give 1. It should give 1. Why is it giving 0? So if we add this line, if we use this line, sorry, if we use both of these lines after the resetting stuff, will that work? No, that doesn't work. Okay, let's just go back to what we had earlier and also recheck the answer here. Okay, still doesn't work. Let me check the previous submission that I made. Oh, I should use a or here. Sorry, my bad. I should use a or here. Yes. Oh no. I should remove this line then. Yeah. Now it should work. Yes, so I used or here so that when the prefix is lower than int min or it is 0, then we will reset it. Okay. So this approach gives us the time complexity of O of n, and thank you for watching. See you later.